Once again, this question is asking us, it's sort of developing what we've been doing all along. So it's designed to develop us to get ready for graphing, but we've been graphing all along. Step one, we always do is find out our non-permissible values to find out if they're holes or vertical asymptotes. Step two, we determine if we have horizontal asymptotes or oblique asymptotes. Then we added step three, which was finding all of our intercepts and any other important points, and then we graphed. So we'll do that again for these ones just to practice everything all the way through. So we always start out by factoring things because that's going to tell us if anything cancels and whether or not we have a hole. It also helps us find our non-permissible values. In this case, x can't equal -2 and x can't equal 2. Those are both going to be vertical asymptotes. Notice when we write non-permissible values, we put the line through to say x can't equal that. But when we write our vertical asymptotes, they are equations. They're the equation of that dotted line, so we put equal signs with it. So to start off with, we already know we have these two asymptotes. Step two, we look at horizontal asymptotes or oblique asymptotes. And so we're looking at which of the three situations do we have. With our highest degree, do we have the highest degree on the top, highest degree on the bottom, or is the degree on the top the same as the degree on the bottom? In this case, we have the highest degree on the bottom. Anytime you have the highest degree on the bottom, you will always have a horizontal asymptote at y = 0. So we can add that one in. X-intercepts, Y-intercepts, step 3. Y-intercept is the easiest one because you just have to plug 0 into our original equation, and that simplifies to 1, so we know we have the point 0, 1. Our x-intercepts in this case, again, you plug in 0 for y, check your factored form. The only time a fraction is equal to 0 is if your numerator is equal to 0. And what would make the numerator equal to 0 would be 4. So again, we have a situation where we have a point on an asymptote, which feels kind of strange. But it can happen. Finally, also in step 3, we need points in each section. Okay? Section 1, we have none, so I'm going to plug in -3 and see what happens. If I plug in -3, and I'll use my factored form right here, -3 minus 4 would be -7. -3 plus 2 is -1. -3 minus 2 is -5. That simplifies to +7/5. So I would know that on my graph, I have -3, 7/5. That looks a little bit low, doesn't it, for 7/5? 7/5 is a little bit higher than 1. There we go. Is that better? Good? Yeah. And so since that point is in that section, We can graph it towards the asymptotes. And this is what we'll get. In between, we've already got a point. We have no more x-intercepts. So this is telling us that this part is going to go like that. And finally, in the last section, at 4, 0, we don't know whether things go up or down because we're right on the x-axis. So what we're going to do is we're going to plug in 3, we're going to plug in 5, and see what happens after those points. Plugging in 3 into our equation, and I'll erase. Plugging in 3 will give me -1 on the top, and 3 plus 2 would be 5, 3 minus 2 would be 1, -1/5. So that's telling me that that section has to be going down. If I plug in 5, five minus 4 would be 1, 5 plus 2 is 7, 5 minus 2 is 3. I get 5, 1 over 21, which means that our graph is coming back up, and then eventually it's going to come back down towards the asymptote. Did I make a mistake with plugging in -3?
Yeah, I think you.
Okay. Let's check that again. Something was bothering me about the -3 as well. -7, right? This would be -1. Oh, and this will be -5, which will give me -7 over +5. Yes, thank you. And so that makes this point negative here. Take out our eraser. And that section will be down there. Yes. Okay? Yes, question. How do I know it's going to go towards this asymptote here? Back down towards the asymptote? Because horizontal asymptotes tell us what happens when x gets really, really big. They don't really tell us anything in the middle. That's why sometimes our graph goes through an asymptote. But if I look at what happens when I keep plugging in bigger and bigger numbers, okay? As I plug in bigger and bigger numbers, subtracting 4 really doesn't have a huge difference. 1,000 minus 4 is still really close to 1,000, okay? 10,000 minus 4 is really close to 10,000, right? 10 minus 4, you might say, I'm not sure if that's really close to 10. But 1,000,000 minus 4 is really close to 1,000,000, okay? And if I put in 1,000,000, I'll get 1,000,000 minus 4, really close to 1,000,000, and 1,000,000 squared, oh my goodness, what number would that be? Million, billion, trillion, minus 4 would be really close to 1,000,000,000. And 1,000,000 divided by 1,000,000,000,000 is getting closer and closer to 0. And the bigger I get, can you see that the bottom gets bigger faster than the top? And so that's the reason why anytime you have a bigger degree on the bottom, your extremes, as x gets really, really big, gets closer and closer to 0. And that's why there's always that asymptote horizontal asymptote at y equals 0. Now, I don't know if it reaches its maximum at 5. You could graph it on your graphing calculator and find out exactly where does it reach its maximum. So it might go up higher for a little bit longer, then come back down. But it will come back down eventually. All right, let's look at the second one. So we start by factoring. Two differences of squares. X plus 2, x minus 2, x plus 3, x minus 3. Nothing simplifies. And so when we go to step 1, our non-permissible values, x can't equal 3 and x can't equal negative 3. So those become both vertical asymptotes. Step 2, which situation do we have? We have the same degree on the top and the same degree on the bottom. This is going to give us a horizontal asymptote. Just look at the coefficients at y equals 1. Step 3, our y-intercept, when you plug in 0 for x, you get 4/9. Our x-intercepts, when you plug in 0 for y, again, the only time a fraction's equal to 0 is when your numerator's equal to 0. So if I look at my numerator, x plus 2, x minus 2, when is it 0? When x is negative 2 and when x is positive 2. Whoops, that one's negative 2, this is positive 2. What's your gut feeling in the middle section? Will it go down or will it bounce off those x-intercepts and go up? Right, because I have no other x-intercepts, and now I know it's going to go like this, right? It's got to connect those points. What do you think is going to happen? Do you think it's going to bounce and go up towards the asymptote or go down towards the asymptote? What does your gut feel? My gut says it's going to go down. It seems like that's how it's going. How would we check that? We'd have to plug in another point, right? We'd have to plug in 2.5. Now, what I might do for 2.5 is not worry so much about knowing exactly what that value is. But what's going to be important is whether 2.5, when I plug it in, is a positive number or a negative number. Because if I plug in 2.5 and it's a positive number, then it would have to bounce and go up. But if I plug in 2.5 and it's a negative number, I know it has to go down. How can I do that easily and quickly? I can look at my factored form there. And just think about positives and negatives. If you plug in 2.5 into this, can you see that that'll be positive? 2.5 into here, positive. 2.5 into here, positive. 2.5 into here, negative. We were right, it goes down. Because a positive times a positive divided by a positive times a negative will be negative. You can also check negative 2.5. Plug in negative 2.5 here, you would get a negative. Negative 2.5 here, a negative. Negative 2.5 there, a positive. Negative 2.5 there, a negative. Multiply all those negatives and positives together. Will you get a positive number or a negative number? Negative. So we were right that this goes down. Now we've only got our one section. We do have to find our other sections as well. So before we get to part 4, which is graphing it, we're going to need to find out some other values as well. So let's plug in negative 4 and positive 4 and see what we get. Again, I'll use my factored form, so I'm going to get 6 here, 2 there, 7 there, and 1 there. I'm going to get 12/7, which is a little bit more than 1. And I'm going to plug in negative 4. If I plug in negative 4, I'm going to get negative 2, negative 6, negative 1, negative 7, which is 12/7 again. So sometimes we need to add some more points to get an idea. Again, we're just creating a sketch as accurate as we can. As you go further along in calculus, you learn more techniques to become even more accurate. But here's the sketch of what we have. Okay. Questions 9 and 10 for some more practice. Again, graph every single one of them.